Today we're going to look at how we can work out the position of the electrons in an atom, and we can call that the electron arrangement or the electron configuration. You're going to need to know how many electrons there are in the atom you're interested in, so if you haven't already watched the video about how to work that out, I would go do that now and then come back to this video. Assuming you've watched that first video, we're going to start off, we're going to look at this periodic table square, and we're going to quickly work out the numbers of the subatomic particles. So, because the atomic number, which is also called the proton number, is 4, that tells us there are 4 protons. And as we know, this whole atom is uncharged, so the positive protons must be balanced out by the negative electrons. Now, in terms of the neutrons, we know that it's the protons and the neutrons together which give the atom its mass. So there's a mass of 9, 4 of that comes from the protons, so whatever is left over when we take them away must be the number of neutrons. Now, for this electron arrangement, all we're interested in actually is the electrons here. And you'll see that where the nucleus is, we're not going to bother drawing the protons and the neutrons, we're just going to put a little black dot, or sometimes we might write the symbol for the element we're interested in. We're just not even going to go there. So, you're ready to do your electrons because you know that you've got 4 of them. So there are 2 rules that you need to know. The first rule is that you always go from the inside out. So these little dotted lines here are our shells, our imaginary lines where the electrons fly, and you have to fill up your first shell before you're going to move out. And the second thing you need to know is how many electrons you can fit in each one. So those electrons, they've got a negative charge, and if you try and put them too close together, it's kind of like magnets. They're going to repel each other and push each other out the way. So in this first shell, there's only actually room for 2, and then in the second shell, there's only going to be room for 8. So I've got 4 electrons. I have to start with my first shell, always with my first shell. So there's room for 2, so I'm going to put 2 in. And you might see some pictures where they get drawn together in pairs, but that's not really something that we need to worry about until we start getting to A level. So I've got 2 in the first shell, I had 4 to start with, so I've got another 2 left over, and they are going to go in my second shell. Okay, so I've got 2 there and 2 further out. Now, if I want to just write down in numbers where those electrons are without drawing all of this, then I can write it like this. So, in the same way that you have to start on the inside and work out, the first number is going to be the first shell. So I've got 2 in my first shell, so I write 2, then a little comma, and then I've got 2 in my second shell, so it's 2 again. Okay, so that's us basically done. So if we look at another example, if we look at carbon, we're going to do the same thing again. So our proton number is 6, that means we have 6 protons. We must have another 6 electrons to balance out those 6 protons. And then the neutrons, we're going to do 12, take away 6, which gives us 6. And again, it's the electrons we're interested in. And we know there's room for 2 here and room for 8 here. So I start off and I put in my first 2. You're going to do that for every single element except for hydrogen, because hydrogen only has 1 electron. And now I've got room for 8 in the next shell, but I don't have 8. I had 6, I've used 2, so there's another 4 left over. So I'm going to put them in. And again, if I didn't want to draw this, if I just wanted to write it down, I could say there are 2 in the first shell, comma, 4 in the second shell. Now, some of you are going to be wondering, what do you do when you have a bigger atom? Because here we've only got room for 10 electrons, and we know that there are bigger atoms than that. So, we've got room for 2 in our first shell, 8 in our second shell, 8 in our third shell, and after that we kind of stop drawing these diagrams because it gets complicated. So if we have a little look at aluminium, we've got a proton number or an atomic number of 13. We need 13 electrons to balance that out. And to figure out our neutrons, we're going to do 27, take 13. So again, this is the number we're interested in. So I've got room for 2 in my first shell. I am always filling from the inside out. I cannot move on until that first shell is full. So I had 13 electrons. I've used up the first 2. And now into my second shell, I'm going to put 8. So I had 2 in the first shell, I've got 8 in the second shell, that makes 10 in total. I've still got 3 left over. So I'm just going to put them in this outer shell here. And again, if I didn't want to draw this, if I just wanted to write it, I could write 2, 8, 3. And that's my electron arrangement done.